Hey guys, how's it going? Hopefully if you're watching this video, you've submitted your test already. Alright, today we're going to be doing circle trigonometry. But talking about the test, I will hopefully have those graded by Monday. The way that's going to work is I'm going to make something called a rubric on Google Classroom. It'll let me tell you the number of points you got on each question. And that's all I plan on doing. So I'm not going to tell you why you lost points. If you want to know why you lost points on something, you can just leave me a quick comment. Right? But please take a look over your test again if you lost points on a question, and only if you can't figure out why you lost any credit, then send me a message. Alright, and that was also my first online test, so if you have any comments or suggestions or feedback about how I can improve for the next test, then please let me know. Was the test too long, too short, too hard, too easy? Did I give enough time? Did I give too much time? All right, just let me know how you think it was. It'll let me do a better job for the next one. So today, circle trigonometry. I'm going to try to draw a circle. And I'm going to try to center it on the origin of this XY axis. And that looks pretty good. Alright, so what I've attempted to draw here is something called the unit circle. The unit circle. So that word unit, that's one unit. So this is a circle of radius 1. So if the radius of this circle is 1, and it's centered at the origin, 0, 0 there, well, let's think about this on a coordinate plane. What would this coordinate be over here? Well, if the radius is 1, that would have to be 1, 0. Right? This point here would be 0, 1. This point here, negative 1, 0. And this point down here, 0, negative 1. Right? So the first thing I'm going to do is I'm going to draw an angle on this unit circle. So the way drawing an angle works is we're going to start at the origin. And an angle is always made up of two sides. So the first side is always going to be along the positive side of the x-axis. Right? And that's going to be the initial side of our angle. And I'm going to draw it until some terminal side, let's say over here. Alright, so that's the terminal side of our angle. And this guy, this will always be the initial side of any angle. And the measure of angle theta will be there. And notice I drew a little arrow here because we know angles, when they're measured in a counterclockwise way, that's a positive degree measure. Right? So this way is positive. Counterclockwise, we know theta is going to be positive. And if we're going this way, right, clockwise, that's a negative angle measure. So for example, if I drew my terminal side here, right, that would be a negative angle measure. And the reason I need arrows, because even if I drew my angle here, I could make my theta look like this, right, and that would be a positive angle. So important to indicate which direction you're going. So we got a terminal side and an initial side. And where this terminal side intersects the unit circle, I'm going to call that a point. I'm going to call that A, B. Right, next I'm going to drop down a perpendicular to the x-axis from that point, a comma b, perpendicular to the x-axis, and there we go. So we got a right triangle. So the first question I got to ask you in this right triangle is, what is the length of the hypotenuse? Well, if you notice, we're in the unit circle. So this hypotenuse is a radius, and the radius of the circle is 1. So the length of the hypotenuse is 1. All right, next, what are the lengths of the legs? So let's start with the height of the triangle, this leg. If that point's a comma b, right, wouldn't you agree that this is a value of b there on the y-axis? So this leg also has a length of b. And if we're looking at the x-coordinate, right, over here on the x-axis, that would be a. So the length of our other leg is a. And just trying to pick a color. Alright. And that length is going to be a. So, if we do our basic trig, we can say cosine of theta is equal to adjacent over hypotenuse, that's a over 1. And if we did sine of theta, that would be opposite over hypotenuse. For angle theta, that would be b over 1. Right, we're dividing by 1, so of course cosine theta is just equal to a, and sine of theta is just equal to b. Alright, so how is this helpful? Well, if you notice, cosine theta is equal to just the x-coordinate of where our terminal side intersects the unit circle. And sine of theta is equal to the y-coordinate, just the value of b. And this would be true for any angle I drew, right? Because if I made that my right triangle and call that a comma b, right, the same exact scenario would happen. This would work for any angle theta. So in general, we can say that cosine theta is equal to the x-coordinate where the terminal side of our angle intersects the unit circle. Where terminal side of angle intersects unit circle. Alright, sine of theta was the y-coordinate. So I'm just gonna copy and paste this. And there we go. Right, and what is tangent? Well, tangent is, again, opposite over adjacent, so b over a. But b was equal to sine theta, right? And a was equal to cosine theta. So we already showed this definition before, but we can also say tangent of theta is equal to sine theta over cosine theta. Alright, so why are we doing trig in a circle, in the unit circle? Well, so far our trig has been limited from 0 to 90 degrees, and you'll notice that still works for 0 and 90 degrees. This unit circle is actually pretty helpful, because if I ask you, what is the sine of 0 degrees? Well, didn't we say sine is equal to the y value? So 0 degrees, it's going to be sine of 0 is 0. What's cosine of 0? That's going to equal the x value, right? So cosine of 0 degrees is equal to 1, right? This says sine of 0 degrees is equal to 0. Oh, that's pretty helpful, right? We can also do the same thing for 90 degrees. But why this unit circle is so powerful is, well, now we can think about angle measures that are more than 90 degrees. That could be our angle theta. And the same thing would also apply. Right? This could be our angle theta. And then this point would be A comma B still. Right? So let's take an example of an angle measure and let's see what happens. So I'm going to copy and paste this. Copy. Paste. And instead of a random angle measure, let's make this, for example, 60 degrees. Well, do we know what the sine and cosine of 60 degrees are? Hopefully we do. But if you forgot, let's just do it one more time. Alright. So if it's 60 degrees, this here would be 30 degrees, right? And the ratio is 1 to 2 to radical 3, or 1 to radical 3 to 2. Right, and the 30, 60, 90 right triangle. So we know opposite the 30 degree side, it's going to be half the hypotenuse. Right, this would be a length of a half. And the longer leg is going to be radical 3 times the shorter leg, so this would be radical 3 over 2. Right, so this coordinate here would be 1/2, comma, radical 3 over 2. Right, and we could do the same thing for a 45 degree angle and a 30 degree angle for theta, for this angle here. Alright, so we know the sine and cosine of 60 degrees. Right, we can say sine of 60 equals opposite over hypotenuse. Our hypotenuse is just 1. Right, it's just radical 3 over 2. And again, it's just the y value of that coordinate. Right, and what is it? The cosine of 60 degrees is a half. Right, adjacent over hypotenuse, or in this case, just the adjacent side if we're talking about the unit circle. So I could draw another angle with a terminal side here that has the same height, right, and the same length as that leg. So if I made this angle, that's 60 degrees, if I made this angle, let's say 120 degrees. Well, let's figure out what sine and cosine of 120 degrees are. So the way we're going to draw this triangle is I'm going to drop down this height, and then I'm hoping you guys realize that these two triangles here, this triangle and this triangle, these are congruent triangles. Right, because if this is 120 degrees, well then this here, this piece here, this is also 60 degrees. And if that's also 60 degrees, right, this height here, this would also be radical 3 over 2. Right, this would also be a length of a half. But on the coordinate grid, this would be negative 1/2, comma, radical 3 over 2. But the angle we're measuring now is this angle, 120 degrees. So we could say something like the sine of 120 degrees is equal to, well, we're going to use our alternate definition of sine here, which is it's the y-coordinate where our terminal side intersects the unit circle. So sine of 120 Well, that's also equal to radical 3 over 2. And cosine of 120 degrees, right? We're doing sine and cosine of angles more than 90 degrees now because we're outside of the right triangle, right? Cosine of 120 degrees, well, that's going to be negative a half. And we can also get a congruent triangle in the third quadrant and the fourth quadrant. So for this 120 degree angle, the triangle we draw is this triangle. So we know the angle we're really looking at is 60 degrees. So this angle over here, we call this a reference angle. It's the angle we use as a reference to find the values for 120 degrees, the cosine and sine values for 120. So we call that a reference angle. So what would the reference angle be in the third quadrant? Well, it'd also be 60 degrees if we're trying to draw similar triangles or congruent triangles here, right? And the actual angle measure, well, it's going to get kind of messy. But if from there to there, right, that's 180. If I go 60 more, then the angle I'm looking at is 240 degrees. All right, so if my terminal side is here, this would be 180 plus 60, that'll be 240 degrees. But the reference angle I'm looking at, it's still this, right over there. So this coordinate, right, both my x and y values will both be negative. This will be negative a half, comma, negative radical 3 over 2. Right, and if I drew it in the fourth quadrant, let's think about the angle measure here. Right, I'm just going to write the angle measure on the line to keep it less cluttered. So that's 240 degrees. Over here, if I want this to be 60 degrees again, when I draw in my right triangle, right, we know there's 360 in a full circle. And so if this is 60 degrees, then this angle measure, starting from my initial side, right, this would be 300 degrees. And this point over here is going to be a half, comma, negative radical 3 over 2. So in the first quadrant, both sine and cosine are going to be positive because x, comma, y, they're both positive coordinates. Over here, cosine is going to be negative, right, because the x value will always be negative in the second quadrant. In the third quadrant, both cosine and sine will be negative. And the fourth quadrant, cosine is going to be positive because we have a positive x value, and our y value will be negative. The value of sine will be negative in the fourth quadrant. So this is our unit circle. We need to be able to do this for 30 degrees, 45 degrees, and 60 degrees. All right, and don't worry about this line over there. You'll do that in Algebra 2. All right, before a 30-degree angle, right, this is our unit circle, so we know this is 1, 0. We know the hypotenuse is 1. Right, so see if you can figure out what the coordinates are for this point, right, this point, and that point. So we did it for 60 degrees. See if you can do it for 30 degrees and 45 degrees. All right, so if you did it for 30 degrees, this point over here, this is going to be radical 3 over 2, comma, 1 over 2. 45 degrees is going to be radical 2 over 2, comma, radical 2 over 2. And this is going to be 1/2, comma, radical 3 over 2. 60 degrees. Right, and we know the x comma y, this is really just cosine theta comma sine theta. So in this quadrant, what's positive and what's negative? Well, everything's positive. So our value of cosine is positive because our x coordinate's positive. Our y coordinate's also positive, so sine theta is also positive. And let's also talk about tangent of theta at this point. Right, we said tangent was sine divided by cosine. So if both sine and cosine are positive, tangent's also going to be positive. Right, and of course we also have 0 degrees and 90 degrees. So how can this unit circle help us? Well, if you look at these coordinates, you can say, all right, cosine of 30 is radical 3 over 2, because that's the x-coordinate. Sine of 30 degrees is a half. Sine of 60 degrees is radical 3 over 2. Cosine of 45 degrees, looking at that coordinate, that's radical 2 over 2. But if we extend this to the other quadrants, well, this lets us get trig values for angles that are more than 90 degrees. So if I look at this angle, for example, right, I see that has a reference angle that goes with 60 degrees. And I notice just by looking at it, right, so I know this angle here is 60 degrees, which means this is 120 degrees. If I look at this angle here in the middle, it's probably a good idea to highlight it, right? I know that's going to be corresponding with the 45 degree angle. So this piece here is 45 degrees, right? If the entire thing is 180, 180 minus 45, this is 135 degrees, right? So 135 degrees has a reference angle of 45 degrees. So when I say reference angle of 45 degrees, I mean it has the same coordinates as this 45 degree angle, right? The coordinates will be the same, just the signs will be different. So over here, this will be negative radical 2 over 2, comma, positive radical 2 over 2. And this one over here, this would be 150 degrees. Right, our reference angle will be 30 degrees here. Right, if that's 30 degrees, this is 30 degrees. So the reference angle for 150 degrees is 30 degrees, which means, again, the coordinates will be the same, just our x value will be negative. So this will be negative radical 3 over 2, comma, a half. So in this quadrant, right, our values of cosine are negative, but our values of sine are positive. Right, the x-coordinate's negative, the y value is positive, so sine is positive. So for 120, right, this will be negative 1/2, comma, positive radical 3 over 2. And so now we know our sine and cosine values in the second quadrant. And this angle over here, this is 180 degrees. Right, so this coordinate, that would be negative 1, comma 0, which means cosine of 180 is negative 1, sine of 180 is 0. And then we're just going to rinse and repeat in the third and fourth quadrants. Right, in this quadrant, both sine and cosine will be negative. Right, just think of it like if this were negative 3, comma negative 3, for example, which it is not, of course. But both cosine and sine will be negative in that quadrant, which would make tangent, by the way, positive, because a negative divided by a negative is positive. If you go back to this one, tangent would also be negative, right? Because it's sine over cosine. Sine is positive and cosine is negative, though. So positive divided by negative is negative. And let's keep going to fill this out. Just for a little bit more, I'll have you guys finish the rest of it. Well, I'll just give you a couple more angles. So this angle measure here, right, that's 180. And that's going to be 30 degrees more. So this will be 210 degrees. So our reference angle for 210 is 30 degrees. And what that means is, once you get this reference angle, all you need to do is look at these values over here, radical 3 over 2 comma a half, right? And the reason I can do that is, of course, if I just draw in the right triangle here, and we do a dirty 60-90 stuff again, right, we're going to get the same exact lengths for the two legs. And that's going to end up being radical 3 over 2 and a half. And if you just take into account the signs, this will be negative radical 3 over 2, comma, negative a half. Right? This next one will have a reference angle of 45 degrees from there to there. 180 plus 45 is 225. So this over here is 225 degrees. Think of the coordinates, think of the coordinates, think of the reference angle. Alright, so whenever you draw a reference triangle, make sure you're drawing it to the x-axis, like so. So for homework today, all I want you to do is to finish this unit circle. Alright, I'll post a completed version on Classroom for you guys to check. But I know this is quite a lot, circle trig. It's always a big jump from just right triangle trigonometry because there's just so much more to consider.